All right, scholars, this week we're going to be working on fractions. We're going to be working on fractions. Absolutely. I know that before we moved to online learning, we spent a ton of time on fractions. I'm going to begin today with just a review about fractions using some snazzy new special effects that I learned. And I really want you guys to pay attention because we're going to be using these like very important skills that we go over today all throughout this week and even next week as we talk about fractions. So let's get into it. Went ahead and made my video a little smaller so that we could see. So why fractions now? We just reviewed multiplication. We just reviewed division. So you guys might be thinking, why are we talking about fractions now? We're talking about fractions now because fractions and division are similar. They're similar. So the process of practicing division, which we've done for the past couple weeks, is actually going to help us with fractions. So I decided that we would learn our fractions unit next. So you might be wondering, how are fractions and divisions similar like this little friend here is? Well, fractions are similar to division because in both cases, we are splitting or dividing something into equal parts, into equal. Yeah, we're taking something and either dividing it or splitting it into equal parts. So they're similar in that way. So we know that they're similar, but just like we do in any good compare and contrast example like in ELA, we can also contrast or talk about how fractions are different than division. So how are fractions and division different? Well, in division, my video is making this a little hard to see right now. So in division, we split whole numbers into equal groups like this, right? So in this case, we have a whole number of hearts. We could count all of 1, 2, 3, 4, 5 hearts. And we know there's 1, 2, 3 groups or 3 groups of 5. Sorry, 3 times 5, 5, 10, 15. So there's 15 hearts. We split them into 3 groups. There are an equal amount of 5 hearts per group. Fractions, on the other hand, with fractions, instead of taking individual objects necessarily and splitting them into equal groups like we do with division, in fractions, we take whole objects and we split them into equal pieces like this. So in this case, they took this whole circle, they split it into 1, 2 equal pieces in this case, or they split it into 1, 2, 3 equal pieces in this case. So in division, over here, we're taking a certain amount of objects and splitting them into equal groups with the whole objects in each group. In fractions, we are splitting whole objects into equal pieces. So what is a fraction? A fraction is a number that represents equal parts of a whole object or set of objects. I'm going to read it again, and just like we would in class, if I repeat something in Snap, I expect you to say it with me. So a number that represents equal parts, that represents equal parts of a whole, of a whole object or a set of objects or of objects. Good. What I mean by that is, in this case, the fraction here, which we will go over how to read, the fraction here, which most of you will recognize as 1/4, that refers to the amount that is shaded of the whole square. So in this case, the square was split into 1, 2, 3, 4 equal parts. One part of that is shaded. So we know that that amount of this little shaded red area is 1/4 of my whole object, of my whole square. When it comes to a set of objects, we can mean that in this case, we consider these 4 circles one group, or a set. We see of these 1, 2, 3, 4 parts, it takes 4 circles to make one set. One of the circles is shaded. So that means 1/4 of my circles are shaded. 1/4 of my set is shaded. This is a really important part. Fractions must have equal parts. So in order for us to be analyzing our objects as a fraction, the fractional amount of the shaded object, for example, those objects need to be broken into equal parts. We can also call these equal shares. You might run across some questions that say that. Equal shares is also a really great way to think about equal parts, since we know when you share something, you should be splitting it equally, right? Or else the people you're sharing with aren't going to think you're a very nice person. You're not being fair. So, equal parts or equal shares are very necessary for a fraction because, in order for us to say, for example, that 1/4 of this whole square is shaded, I need to know that each of these pieces are equal. If each of those pieces are not the same size, I can't be sure that one piece is a fourth of the square. Let's practice identifying equal parts together. So, quick. Are the pictures that I'm about to flash you split into equal shares? What I want you to do is I'm going to give you about 1 minute to look at each of the pictures, and you're going to decide if those are equal shares. After the minute is up, I will reveal to you, and we can see how we do. Are each of these pictures split into equal shares? You have 1 minute. Go. Remember, equal shares means equal pieces. So are these split into equal pieces? You have about 30 seconds left. You are evaluating each of these pictures. About 15 seconds. Alrighty, let's chat. Quick, are these split into equal shares or equal pieces? Let's start with this guy up here, this triangle. Is this triangle split into equal shares? Agree or disagree? I really hope you have a disagree thumb up right now because no, this triangle is not split into equal shares. We can see here that this little red piece, that is not the same size as the piece next to it. That piece next to it is a lot bigger. Think about it this way. If you couldn't divide this triangle up and have every person who got a piece be happy with their piece, it's not going to be equal. Like, I'd be pretty angry if you handed me a piece of a cookie that big and then you got this piece. That's not fair at all. So, no, those are not equal shares. All right, let's talk about this guy. Is this pizza split into equal shares? Agree or disagree? Yeah, agree. It totally is. Each of those slices, despite the fact that there's different toppings, I don't think you can order a pizza like that. Each of those pieces are about the same size, so those are equal shares. Ding, ding, ding. That one's an absolute winner. All right, let's talk about this guy here. Just like house looking thing. Is this house split into equal pieces? Could I determine the fractional amount of that piece? No, not really. We can even look at the shapes that are in this. Like, I see a rectangle here and then a big triangle on top. Those are not equal pieces. I could not determine the fractional amount of each of one piece. What about this guy? Yep, it is. I thought this was a really fun example because it's like little Legos. You can totally use Legos to be thinking about fractions. So I see that each of these little Legos is about the same size, right? Each of these are this, well, not even about, they're exactly the same size. So when they make this rectangle, this green piece is the same size as I think that the yellow piece and that blue piece. So I could look at that green piece and be like, yeah, that green piece is one equal piece out of 1, 2, 3, 4 pieces. That green piece is 1/4 of our whole rectangle. All right, last but not least, this triangle, not a triangle, Miss Cup has got 4 sides, diamond looking thing. Are each of these pieces equal? Yeah, no. If you had a thumbs down for that, ding ding, you're a winner because let's look at this, right? I see this little triangle here. Is that the same size as all the other pieces? No, it might be the same size as this piece here, but these two pieces are definitely bigger. So this is not split into equal pieces or equal shares. Awesome. Let's continue on. As a reminder, if you're a Hadley friend, you know that I always like to describe fractions as codes. We know that we're always math detectives in a VCP math classroom. And when it comes to fractions, we super duper got to stick that detective hat on because fractions are basically codes. The numbers in our fraction give us secret messages. We can read the parts of a fraction like a code to tell us important information about how many equal pieces make one whole, how much of the whole we have, so how many pieces we have, and the name of each equal piece. So remember, if we read a fraction correctly, if we know how to read a fraction like the code that it is, we can get so much information, including these 3 very important pieces of information. You're about to watch a video now. Oh, it tried to play without me. You're about to watch a video now. And when you're watching the video, I really want you to pay attention how we can read and write a fraction so that you can answer these questions below. They are the exact same as the three that I just mentioned, but I want you to be able at the end of this video to tell me what part of the fraction tells us how many equal pieces make one whole, what part tells us how many equal pieces of one whole we have, and what part tells us the name of each equal piece.
Wait, stop. You're supposed to share with the whole class. Moby, that's not fair. Everyone is supposed to get equal parts of the sandwich. What is a fraction? A fraction tells you the number of parts out of a whole. Not that kind of whole, Moby. Something is whole when it has all of its parts. I love muffins. This whole muffin has 2 equal parts. In a fraction, the number of parts goes under a line. There are 2 parts. You took 1 part of the muffin, and that number goes on top. So this fraction shows you took 1 out of 2 parts. You can also write this as 1/2. What is a half? When you split something in half, you make 2 equal parts. Right, Moby, there are 2 halves in a whole. Half for you and half for me. There are 2 equal pieces, and we each get 1 piece. Sometimes I see a half moon at night. And everyone loves a half day of school. What is a third? We can share this cake between you, me, and Grandpa. We can cut the cake into thirds. That means we divide it into 3 equal pieces. We each get 1 slice. So Grandpa gets 1 out of 3 slices. We each get 1/3 of the whole cake. There are 3 of us, but only 1 is a robot. So 1 out of 3 of us is a robot. What is a fourth? I love apple pie, and this pie has 4 equal slices. You took 1 slice. So you took 1 out of 4 slices, or 1/4 of the slices. I can divide a lot of things into fourths, like a piece of paper, a cup of water, an inch, or an hour. I think all this sugar is making us sick, Moby. We better cut up the sandwich so everyone can get an equal piece. It's okay, Moby. I've got a slice saved right here. Wait, you're supposed to give me half. I guess you can keep mine.
So after watching that video, let's put it to the test. I hope you were paying attention to when Annie was describing how she was writing that fraction. She did such a fantastic job. I almost even paused it, but I wanted the video to keep going. She did such a fantastic job of describing exactly how to read fractions or write fractions like the codes that they are. So let's review. We know that parts of a fraction can be read like a code to tell us important information about these 3 things: how many equal pieces make one whole, how much of the whole we have, or how many pieces we have, the name of each equal piece. So let's put it to the test. Where can we find this information? Let's look at this fraction here. I'm not going to say it because I really want to make the point. What part does the number or the digit on top or the digit on the bottom tell us how many equal pieces make one whole? If you think it's the digit on the top, I want you to raise your hands to the sky. If you think it's the digit on the bottom, if you think it's the 3, put your hands under the whatever surface you're using, under the table, under the desk. In my case, I'm using a desk. Which part of our fraction tells us how many equal pieces make one whole? All right, ready? 3. We're going to do 2 thumbs, and then you decide. Ready, go. There's a reason you can't see my hands. Yeah. The bottom digit, this digit here, in this case 3, that tells us how many pieces make one whole. So I know that if I were to draw this, like maybe I'm going to draw it right here. So say I have this rectangle here. I need to split it into 3 equal pieces. Those don't look quite equal, but I need you to work with me. I need to split that into 3 equal pieces in order for me to find this fractional amount. All right. Which part of our fraction tells us how much of the whole that we have, or how many pieces we have? If you think it's the digit on the top, your hands are going to go to the sky. If you think it's the digit on the bottom, your hands are going to go to the floor. Ready? 2 thumbs on your desk. Hands up. Yeah. Wave around like you just don't care. Yeah. So we know our top digit right here, that tells us how many pieces we have or how much of the whole we have. So in this case, this fraction is telling me out of my 3 pieces in my whole rectangle, I have 1 piece. So I can say 1 piece out of 3 equal pieces, in this case, is shaded. Now, probably one of my favorite code tricks. What digit, the digit on the top or the digit on the bottom, sneakily tells us the name of each piece? All right, make your decision. Ready, here we go. Ready, go. Yeah, you can't see my hands, so you know that this number on the bottom here, this digit on the bottom here, it tells us the name of each piece. Now, I don't call this piece that I shaded in yellow a 3, right? Say no way. No, we got to be like detectives. We have to think. I know Annie mentioned that a whole object split into 3 equal pieces. Each of those pieces are called thirds, yeah, they're called thirds. I know we can use the number of pieces that a whole is split into to determine the name. So I know I would read this fraction as I have 1 piece, and I know each of those pieces is called a third. So I know I read this fraction as 1/3. I know I read this fraction as 1/3. I read it as 1/3. I read it as, yeah, I read it as 1/3 because it tells me I have 3 pieces in one whole, or I have 3 pieces that make up one whole, and I have 1 piece. All right. We know mathematicians have special names for these digits. Before I was being kind of sneaky and I was just saying the digit on the top, the digit on the bottom, but you VCP scholars, I'm sure we're like, Miss Cupp, get to it. We know that those have special names. A mathematician calls the digit on the top, which we know tells us how many pieces or how much of the whole we have, they call it a, drum roll please, the numerator. They call it the numerator. I know that kind of gets a little bit like tongue tied. Just make sure you're saying numerator. You think about that because it kind of looks like the word number, which helps me remind myself that, like, okay, that tells me the number of pieces, the amount that we have. We know that the digit on the bottom, which as a reminder tells us how many pieces make up one whole, and the name of each equal piece, we call that a, drum roll please, we call it the denominator. We call it the denominator. So the denominator, that's the one that tells, it's the digit on the bottom. It tells us how many equal pieces make up one whole and the name of each equal piece. Like I reminded you, my headphone decided to take a dive. Let's put this into practice. So we know we can also use this information, like we talked about on the previous slide, to draw or model our fractions too. So what if I were to change this to this fraction here. How could I use that to model on here, to model in this whole rectangle, the fractional amount represented by this fraction? What I'm about to say is exactly what you should be thinking to yourself when you see a fraction like this, or when you see any problem that has to do with a fraction. You can actually go ahead and do this on your scrap paper. I'm just going to do it on here so you guys can see it and the visual is better. So go ahead and draw yourself this rectangle, or draw any rectangle really. And I'm going to think to myself, okay, I know my denominator, my denominator tells me how many equal pieces are in my whole. So in order to draw this fraction, I need to make this have 6 equal pieces. So what I'm probably going to do is, instead of trying to make them like really skinny like that, I'm going to first split it in half so that I have 2 equal pieces, and then make 3 columns here so that I have 1, 2, 3, 4, 5, 6 pieces. So I know that I have 6 equal pieces here. My fraction, my numerator, that digit on top, that tells me that of my 6 equal pieces, I have 1 piece. So I'm going to shade in the equivalent of 1 out of the 6 equal pieces in my whole. So that's nice and shaded in. Now, if I were to be asked how much is that piece, I know that my denominator, this digit here, also tells me the name of each piece. I know this isn't 1/6. I know it's 1/6. 1/6. You add a th at the end. That's always the little like trick for most of them. There's a couple of fractions that we know have different names. We talked about that a lot throughout the year. But I know that I have 1/6 of my rectangle is shaded in yellow here. It's super important that you include the whole after that. I can't just say 1/6 is shaded, because if somebody couldn't see the screen, or if somebody wasn't as like VCP scholar as we are, they'd be like, 1/6 of what, right? Like 1/6 of the pizza, 1/6 of kids. Like, what are you talking about? So you need to make sure that you're specific about your whole. So we know that 1/6 of this rectangle is shaded yellow. So we just reviewed, remember, so we just reviewed not only the basic components or the basic parts of a fraction, but we also reviewed how to read them like a detective, read fractions like a detective, like the code of they are, in order to get a lot of important information. Let's apply these learnings now to our guided practice. So our guided practice today is going to be a little bit shorter than you might be used to, just because we were doing so much thinking and so much focusing for our review slides. Unlike my paper, your paper probably isn't going to be blank right now, because you should have been following along with the slides. If you weren't, silly you missed out on a really good learning opportunity, kind of a bummer. So we're going to walk through a couple of problems just to really make sure that you know exactly what to do for your independent practice, and to make sure that you're nice and set up for the remainder of the week. If any of these problems feel weird to you, or if they're a little bit tricky, or if the independent practice kind of tricks you up, that's a super good sign that you probably need to head to office hours with Mr. Cody or Miss Hendricks today. They're super pumped to start fractions with you. All right, let's talk about this first story problem really quick. So it says Miss Cupp split a candy bar between 3 people. What fraction of the candy part does each person get? What I'm doing now is exactly what you need to do on your paper. What I draw, you draw. It's like zombie hand. What I'm saying out loud, you're thinking in your brain. So I know if I have 1 candy bar, I'm going to just go ahead and draw my candy bar. And I'm splitting it between 3 people. So I know that I need to split this into 3 equal groups. Those look pretty equal to me. Then it asks me, what fraction of the candy bar does each person get? So how much is each of these pieces? Now, I know I can write fractions in words and numbers. We're going to do both to help us practice. So basically it's asking, how much would one person get? So I'm going to shade maybe this one. How much is each piece? I know that in this case, I'm thinking, okay, I know that I have 3 equal pieces. That number needs to go in my denominator, because that tells me that those are, when I put a number or a digit in the denominator, that tells you how many pieces are in the whole. Of this whole candy bar, there are 3 equal pieces. There needs to be a 3 in my denominator. How much does each person get? Okay, if there's 3 people who are splitting this candy bar and there's 3 equal pieces, each person is going to get 1 piece. So I'm going to put a 1 in my numerator, because that tells me, okay, each person is going to get 1 third, that 3 in the denominator tells me each of these pieces is a third, gets 1/3 of the candy bar. I want you to go ahead and write that. I'll give you about 30 seconds. You need to include this of the candy bar because you need to describe what the whole is. In this case, it's of the whole candy bar. If you're a fast writer, maybe like me, or you were writing along with me and you're already done, I want you to practice writing 1/3 in words. We know that 1/3 is written like this. It's not 1/3, doesn't follow our normal rules. This is 1/3. Annie talked about it in the video as well. So you are going to go ahead and type in. I would like you to type in the words 1/3. Make sure you type it in correctly. It's spelled for you in 2 places now. If you don't type it in correctly, it won't code it as correct. Now, if you did want to type it in for future problems, I'm going to go over that tomorrow. Today, we're just going to practice writing it in words. All right, let's rock and roll on to question 2. It says, how many equal pieces would you divide a whole into to represent the fraction below? So I know that fraction below. I know what it is, but I'm going to think to myself, what is the part of the fraction that I'm actually going to look at? What part of the fraction tells me how many pieces are in the whole? If you think it's the numerator, if you think it's the number on top, put your hands in the air. If you think it's the denominator, the number on the bottom, put your hands under your desk or under your computer. Ready? 2 thumbs on your desk, then reveal your answer. What part tells us the number of pieces we would divide the whole into? Ready, go. Yeah, you can't see my hands because it's definitely the denominator. Reminder, the denominator, I know yellow is kind of tough to see. We'll do it in blue. We know the denominator, that digit, the denominator, the denominator there tells us, that was really silly. We know that digit there tells us that the amount of pieces in the whole, in the. So I know I don't even necessarily need to read this fraction in order to answer this question. I know in order to correctly model the fraction 1/4, because that is that fraction here, I need to have 4 equal pieces. I'm going to look at my answer choices and I find that answer choice here. I know that this isn't correct because I don't even see the number 2 in my fraction, but also I know that if I were to split something into 2 pieces, I would have halves, not fourths. So I'm going to also mark it up on here. To help you, I would just circle the fourth like I did. I know that this isn't correct because 2 equals halves. I know the second choice isn't correct because if I have 3 in the denominator, if I have 3 equal pieces, those are thirds, not fourths. We know that that C option is correct because if there are 4 equal pieces, they are fourths. This is really good practice for writing. Also because, again, 4 is in the denominator there. It's in my fraction. It tells me. And then we know D is incorrect because 6 equal pieces in a whole would mean each piece is a sixth. So it would be broken into sixths. So in that case, we know our correct answer is 4. This fraction 1/4, I would need to divide my whole into fourths or 4 equal pieces. That line should probably go more closer to there. I'm coming back to this slide because this actually has our word of the day on it. I really wanted to make this word the word of the day because I really wanted us to stick it in our brain that in order for a fraction, in order for us to use fractions, we need to make sure that the whole object or the set is divided into equal parts, into equal parts. So today, your word of the day is the word equal because I need us to remember that if the parts aren't equal, we can't determine the fractional amount. We can't just count the pieces that make up the whole if those pieces aren't equal. So the word of the day today is equal. Alrighty, so the third question here, I'm running out of room, so I'm just going to go to the top of my scratch paper. The third and final question is, what fraction represents 1 piece of watermelon? So basically what this question is actually asking me is, how much is each piece of watermelon? What fractional amount is each piece of watermelon? So I'm going to think to myself, okay, one piece of watermelon, that means that's going to go in my numerator because that's the one piece that I have. Now I need to think to myself, okay, how many pieces of watermelon, how many equal pieces of watermelon make up one whole watermelon? So I'm going to count 1, 2, 3, 4, 5, 6. So each piece is 1/6. I want you to go ahead and write that. Each piece is 1/6. I want you to also write it in words. We know we always include the whole, 1/6 of the watermelon. To actually type in your answer, I would like you to type 1/6. One piece of watermelon is 1/6 of the whole watermelon. Now we are done with our guided practice. I promised it would be short today since that earlier video was a little bit longer. That means your independent practice includes some information from the slides. So if you were a silly human and you did not watch the video, which I don't understand how you would do the quiz if you didn't, make sure you watch the video. Or if you get a little bit tricked while you're doing independent practice, reminder that you can always go. And when you click on the video, you can click YouTube, which we know then just opens it in a separate tab like this. This is just a placement video since obviously I'm recording the video right now. I can't put it in here. So you can always pop it up like this. And then when you're doing your independent practice, you can have them next to each other. So again, if you need a little bit of help to do the independent practice, I recommend that you take the lesson video, you click YouTube here. So yeah, click YouTube. That way it opens in a separate tab up there. That way you can go and maybe like fast forward through it to watch some parts again to help you answer the independent practice. You should still be doing this by yourself. However, if you are noticing it's tricky, you need to go to office hours. As a reminder, today's magic word, the video was earlier. Make sure that you go back if you're a little bit tricked, because I'm not going to type it in for you right here. Go back in the video to find the spelling if you need it. Again, you can do the YouTube trick, click YouTube, see up there, get the spelling. It needs to be spelled correctly in order to advance. And then you may rock and roll in your independent practice. Happy Monday, friends.